there was nothing for me to type up for 3.5. All right, 3.6. This 3.6 is the last section of derivative formulas. But before you panic, this section has 6 formulas in it. You only have to memorize one of them. There is one that you will use often enough that I want you to memorize it. The others I would give you on the test. So don't panic when I say more formulas. It's just using formulas mostly to differentiate inverse functions. Now here's what you should remember about inverse functions. F has to be a one-to-one function, or otherwise the inverse doesn't exist. And perhaps you have a function f that's not one-to-one, but you could restrict its domain so that it's one-to-one. Sometimes we only use a restricted domain. But if we have a restricted domain for f, a one-to-one function on the domain D and the range R, then there's a function g with the domain R and the range D. That's the inverse function of the function f, provided the following condition is true for every x in the domain and every y in the range. If you put y equals, let me read that again. Y equals f of x if and only if x equals g of y. In other words, if you put x into the function f and get a y value, you should be able to put that y value into the inverse and get back out the original x. So this is nothing new. This is a review of inverse functions. Other things that you should remember about inverse functions: a function must be one-to-one in order for its inverse to exist. That means it must pass the horizontal line test. The graph of an inverse function is just the reflection of the graph of the function with respect to the line y equals x. And everything typed above number 3 actually comes from number 3. The fact that if the point AB is on the graph of the function, then reverse the ordered pair, and that will be on the graph of the inverse. So if the point 2, 3 is on the graph of the function, the point 3, 2 will be on the graph of its inverse. And that's why the graph of the inverse function is the reflection of the graph of the function. Number 3 is also the reason for this next statement. If f prime is dy over dx, f prime is the derivative of the function f with respect to x. These are two different notations for the same thing. If f prime, the derivative, is the difference in your y's divided by the difference in your x's, and you switched all the ordered pairs, then the derivative of the inverse function would be the difference of the x's divided by the difference in the y's. If you think of this as the slope formula, y2 minus y1 over x2 minus x1, and then you reversed all the ordered pairs, your slope would be x2 minus x1 over y2 minus y1. In other words, the slope of the tangent line to a function f at a particular point AB is the reciprocal of the slope of the tangent line to the inverse at the point BA.
So it would be like, if your slope is 2, then your slope of your inverse would be 1/2?
Yes. Yes. If the slope of the function, a particular function f at the ordered pair 3, 4, if that slope turns out to be 7, then at the point 4, 3, on the inverse function, the slope will be 1 over 7.
Okay.
Well, it really just makes sense. I mean, when you understand it, you just go, duh, I'm switching the x's and the y's, so it makes sense that the slope formula is going to be upside down. It's going to be the reciprocal of the slope of the original function. For example, and I'm just going to show you this one in the book so that we don't have to do one exactly like this. Example 2 on page 176. says, let f of x equal x squared for all x's greater than or equal to 0. Why do we need that restriction on the domain? Why are we only going to use non-negative x's?
Because it's a parabola.
Because otherwise, this is a parabola that doesn't pass the horizontal line test. It wouldn't be 1-to-1. So with that restriction on the domain, only non-negative x's, x squared is only half a parabola. It does pass the horizontal line test, and its derivative would be the square root of x. Show that the slopes of the graphs of the function and its inverse are reciprocals at each of the following points. If I substitute 2, 4 into the derivative of the function, let's see, if the function is x squared, then its derivative is 2x. So if I substitute the point 2, 4 into that derivative, I get that the slope of the tangent line is 4. Now if I substitute 4, 2 into the derivative of the inverse was square root of x, so its derivative, that's x to the 1/2. So its derivative is 1/2 x to the negative 1/2, or this guy right here. If I substitute 4, 2 into the derivative of the inverse, I get the reciprocal 1/4 of what I got when I put the point 2, 4 into the derivative of the original function. Man, I should get paid more for being able to say that. That is difficult to say. It's easier to read and understand than it is to actually say out loud. But the saying out loud is when you really get it. You understand it if you can say it out loud. So we just found the derivative of the function, which was given to us. We found the derivative of the inverse, which was given to us. And then we took the ordered pair 2, 4, substituted it into the derivative of the function. We took the ordered pair 4, 2, substituted it into the derivative of the inverse, and sure enough, the slopes that we got were reciprocals of each other. You have one in the homework exactly like that. You're given the function, you're given the derivative, you're given the inverse, find the derivative of each. All right, I don't want to do one that's just like that one. I want to, there actually was one thing I wanted to show you on the page before when we were reviewing inverse functions. I don't know what function this is. This looks like some cube function that's been shifted up and to the right, maybe. But if this is some y equals f of x containing the point AB, then its inverse would be the reflection of that along the line y equals x. The line y equals x is the dashed red line. And this is the reflection of that about that line. It's like x cubed looks kind of like that, and cube root of x looks kind of like that. And if AB is on the graph of the function, then BA will be on the graph of its inverse. I wanted to show you that picture and this picture on down the page. Again, if we have some solid black function, we don't know what it is. Actually, it is the graph of example number 1. That function at the point 2, 3 has a slope of 4. If we weren't given that the slope was 4, if we were just given this function, how would we have determined that the slope of the tangent line right there is 4?
Take the derivative.
Take the derivative, substitute that point. Actually, you're just going to have the x of that point to substitute. And that's where you get the 4. Now, the inverse function is the one in gray. If the black function goes through 2, 3, then the gray function is going to go through 3, 2. If you found the derivative of the gray function and substituted its x value, the 3, sure enough, you get the slope is the reciprocal of the slope of the other point in the original function. All right. Wanted to show you those two pictures, and then what? actually, let's look at these formulas, and I'll tell you which one you need to memorize and the others you don't. I already have typed you a note about it. The only one of those that you need to memorize is the derivative of arctangent. Number one, it's easy. It doesn't have any radicals in it. And number two, in the problems you do in the homework and the test, you use this one more frequently than you use the others. So if you just remember, the derivative of arctangent ugly is 1 over 1 plus ugly squared times the derivative of the ugly, then I'll give you the other ones. Actually, I'll give you arcsine and arcsecant, and you can remember, just like you did for sine and cosine, the derivative of arc cosine is the same as this with a negative in it. The derivative of arc cosecant is the same as this with a negative coefficient. So if you memorize arctangent and I give you arcsine and arcsecant, then these three are just negatives of those three, or the opposites of those three. We'll have to figure out how to use those. In number 12 through 42, we'll do as many evens as possible. And the first one, number 12, I'm not going to write down number 12, I just want to show you the directions for it. Number 12, I'm sure you can read that. Number 12 says, show that the slopes of the graphs of the function and its inverse are reciprocals at the given points. When you do number 11 in the homework, just look at example 2. You find the derivative of the function, find the derivative of its inverse, substitute the ordered pairs, and show that the slopes are reciprocals of each other. That's the one. I'm not going to do one just like. Number 18 says, find dy over dx. What's synonymous with that? Number 18 says find dy over dx. What's the same set of instructions? What set of instructions would mean the same thing? Find the derivative or find y prime. Those three things would all mean the same, right? So let's do number 18. Number 18, we don't even really have to use anything from this section. We could have done 18 in last night's homework because it doesn't involve any of those inverse trig functions. I wanted to do it anyway because I didn't feel like we got to do as many examples in class as I would have liked to Monday. If I just looked at that problem and the directions on the test said find the derivative, what would have triggered in my mind, ooh, I need to use implicit differentiation?
The y squared and the x equals.
The fact that it would be hard to get that y by itself. The only way to get that y by itself would be change that to exponential form. And if you had it in exponential form, you might be able to differentiate explicitly. But since I don't want to go that route, I'm just going to differentiate implicitly. What's the derivative of the x? 1. And to differentiate the right-hand side, do I need the product rule?
No.
That's just a constant times a function. So keep up with the constant, differentiate the function. What's the derivative of natural log of ugly? 1 over same old ugly. Anything else?
Times the derivative of the
times the derivative of the ugly. What is the derivative of the ugly? Yes, and you remembered the y prime because you were differentiating a term with a y in it with respect to x. And then what?
You get the y by itself.
You know what? If the directions just said find the derivative, I would solve for y prime, and that would be the answer. If it said find the derivative, I wouldn't have to do anything with this point. But if it says evaluate the derivative at this point, I don't have to go to the trouble of solving for y prime. I can put 2 in the place of my y's here before I solve for y prime. I can either substitute and then solve for y prime, or I can solve for y prime and then substitute. Which one would be easier? Substitute first. You're substituting the 2 for the y, and you have 1 equals 2 times 1 over 2 squared minus 3 times 2 times 2 times y prime. So far, so good? Any questions? What's the only thing I would need to do to solve for y prime? Divide both sides by 8. Again, if I had not been told evaluate the derivative at this point, then I would have had to have solved for y prime. But because I'm going to substitute numbers, and it's easier to solve for y prime with just numbers, I'm going to do the substitution and then solve for y prime. I would get the same answer either way. All right. What about 14? I don't know why I did 18 first, but 14 says find the equation of the tangent line to f of x equals arctan x at the point -1, negative pi over 4. What have I always done when the direction said find the equation of the tangent line?
Find the derivative.
First find the derivative and then what?
Find the slope.
Plug the x into the derivative to get the slope at that point, and then use what? Point slope form to find the equation of the line. All right, that's our plan of attack. Now, this is arctangent x, and that's why it's in this section. We have not yet differentiated any inverse trig function. This is the one that I want you to have memorized. From, which you probably don't yet since you only saw it 2 minutes ago. Look at the handout and tell me what f prime of x would be.
Be
1 over 1 plus whatever the ugly is, and in this case just x, squared. Right, here's the formula I'm using. The derivative of arctangent ugly is 1 over 1 plus ugly squared times the derivative of the ugly, but in this case, the ugly is just x, so what's the derivative of the x? Just 1. That's why I only have 1 in the numerator. You could put times 1 if you wanted to. Notice that you're not taking the derivative of the 1 plus x squared, you're taking the derivative of the ugly. And in the original function, the ugly was just x. All right, I have the derivative.
Why did you put times 1 for?
You don't have to. I was just saying that I had it in mind, and since you can't read my mind, I wrote it down. If this had been anything other than x, then let's say it had been tangent of 5x, I would have had to remember to put times 5 there. I didn't have to put times 1, but I wanted you to know I was thinking, hey, the derivative of the ugly. Is that okay now?
Yeah.
I thought we did do the derivative of the ugly on the numerator.
Yep.
Yeah. Okay. I see your point. The way that I read this formula to myself outside or out loud, either one, out loud, outside. When I'm thinking this formula, the words in my head are 1 over 1 plus ugly squared times ugly prime, but that does put ugly prime in the numerator.
Gotcha.
So, no. Either way, same thing whether you write that 1 or not. All right, that's the derivative, and then what?
Substitute -1 in place of x.
Because that will give me, what's the words? Slope of the tangent line at that point. F prime of -1 is 1 over 1 plus -1 squared, better known as 1/2. Then what?
Then you plug into this.
That's my slope. I have a point and a slope. I use point-slope form. Y minus -pi/4 is y plus pi/4. Equals m times x minus -1 is x plus 1. And then for me, you're always going to get your answer in slope-intercept form. All for y. Y equals 1/2 times x plus 1. I'd go ahead and distribute the 1/2 and subtract pi/4 from both sides. You don't have to get a common denominator and add the 1/2 and the negative pi/4. So we had a new formula, but other than using a new formula, we didn't do anything new there. That means tonight's homework's going to be a little bit easier than last night's homework. Mr. Warren?
Okay, I know this is going back a bit, but
That's
on the
okay.
equation of the tangent line on the test,
Yes.
instead of doing point slope form, I think I did y equals mx plus b, and I solved for b.
That's
So that
okay.
is the answer too? Okay.
Yes, that's okay, and that is what some people do instead of point slope form. That
I think I got
works.
that one wrong, so that's why I was asking if
It
that...
wasn't because your process was wrong, though. You must have just made a mistake.
Yeah,
The
I was-
process would have worked.
Uh,
All right. Well, talk about that in just a minute. Let's go on and do something else right now. But I'll show you, or Warren can show you after class. All right. Seems like there was. Oh, I was going to show you this on the calculator, and I think it may take too long, but so I'm not going to. But do you remember what the graph of tangent basically looks like between its asymptotes? It kind of looks like x cubed between its asymptotes. So what does the graph of arctangent look like? Cube root of x. All right? So I'm just giving you a rough idea of what it would look like if you graphed this on your calculator. The asymptotes for arctangent would be where? Where is tangent 0? Negative pi/2 and positive pi/2. So if I were graphing tangent, I'd put negative pi/2 and positive pi/2 on the x-axis, dash in those vertical asymptotes, and then put a graph that kind of looks like x cubed. When I'm graphing its inverse, then the domain, the negative pi/2 and pi/2, go on the y-axis because that's the range of the inverse function. And then the graph kind of looks like cube root of x between those horizontal asymptotes. Here at the point -1, -pi/4, here's the tangent line. This is fun to do on a calculator. If we graphed arctangent x and our answer to this problem, then the calculator would graph arctangent x, and then it would graph that line, and that line would be touching the graph of arctangent x at the point -1, -pi/4. Y'all just do that for a 3-0 when you get home. All right, let's do another problem using a different formula, a formula that I would provide to you on the test. Number 20. How about that? Woo. That's some scary stuff right there. Except for, I know that arctangent, I have that derivative memorized, and this one I'll give you on the test, so you don't have to worry about that. Maybe it's not as bad as it looks. Can you differentiate that explicitly, or should you use implicit differentiation? You're gonna have to use implicit unless you solve that for y. Well, you can't solve that for y because it's not just y times the arcsine of x, it's the arcsine of xy. So no, I don't want to solve it for y. I want to use implicit differentiation. And I have the formula that I would give you on the test. I'm going to write it right here so you can see it. All right, I'll give you that on the test. You just have to know how to use it. On that left-hand side, what is my ugly? XY. So when I find the derivative of it, I'm going to have to use the product rule. All right, so the derivative of arcsine of ugly is the derivative of the ugly. I'll get back to that in just a second. Over the square root of 1 minus ugly squared. What's wrong with what I just wrote? I haven't squared the whole ugly, I've just squared the y. Use parentheses when you need them. So that's going to be the denominator. The numerator has to be the derivative of that ugly by the product rule. So first, times the derivative of the second. What's the derivative of the second? Y prime. Plus the second times the derivative of the first, which is just 1. Don't have to write 1 as a coefficient. That's the derivative of the left-hand side, correct? All right. Right-hand side is a different formula. It's the formula I have memorized. And what's the ugly on the right-hand side? 2x. Do I need the quotient rule for 2/3 arctangent ugly? No, that's a constant times a function. I just need to keep up with the constant and differentiate the function according to the formula which I have now memorized. The derivative of arctangent ugly is 1 over ugly, just going to leave the numerator blank for a minute, times 1 plus ugly, has to be in parentheses, squared. And then what goes in that numerator? Derivative of the ugly is just 2. Now, if the directions were just find the derivative, what would I have to do? Solve for y prime. That'd be kind of bleh. I could. But if the directions aren't find the derivative, but find the derivative evaluated at this point, what may be the easiest thing to do next? Plug the point and then solve for the y prime. You could do either way, but most people are better at solving for y prime with numbers in the equation than with other variables in the equation. So I'm going to put 1/2 in place of all the x's and 1 in place of all the y's. I'm not saying it's going to be pretty. If you can do that without writing neatly, I want to shake your hand, because I can't process that unless I have it written fairly neatly. Let me double check. 1/2 in the place of x, 1 in the place of y. All my parentheses, my radical in the right place. On the right hand side, I went ahead and said that 2 times 2 is 4 in the numerator. In the denominator, 1 plus 2 times 1/2 squared. If you see a mistake, tell me now, because I don't want to work 10 more minutes and find out that I've made a mistake. Are we all on the same page?
Yep.
All right. Let's keep going. In the denominator, do as much as you can at once, but when you cease to be able to do something in your head, that's where you need to stop. 1/2 times 1, that's a half. A half squared is what? 1/4. 1 minus 1/4 is 3/4. So maybe I'm going to stop there. I'm going to say that's in the denominator, that's square root of 3/4. Now maybe we could have taken one more step in our heads, but I didn't want to skip stuff that I was going to have to explain later. On the right hand side, 2 times a half is 1, 1 squared is 1, 1 plus 1 is 2, 2 times 3 is 6. Well, yeah, thank goodness something was simple.
Wait, say that again. Because I'm thinking you.
2 times a half is 1. 1 squared is 1. 1 plus this 1 is 2. And 2 times 3 is 6. Other than reduce the 4/6 to 2/3, what would you do next?
Multiply both sides by square root of 3/4.
You can multiply both sides by square root of 3/4. Yes, ma'am?
Would it be easier to change the square root into a half and then?
No, I don't think so. I don't think it would be easier to change that to the exponent 1/2. It would be if we were working with variables, but we're not working with variables here. Now, I am going to do one other thing in my head, or one other thing in this step. I'm going to say square root of the fraction 3/4 can be broken apart into what?
Square root of 3 over 2.
Yeah, that's just square root of 3 over 2, because the square root of 4 in the denominator is just 2. And then course, on the right-hand side, the 2's would cancel. I just have square root of 3 over 3. What else can I do in the next step?
Subtract the 1.
Subtract 1 from both sides. And then what? Multiply both sides by 2. And I can, on a test, if you get this far, I am so overjoyed that that's beautiful. That's perfect. You don't have to do anything else. In the back of the book, just because it wouldn't be difficult, I suspect that they will have written that 1 as 3 over 3 and call that numerator 2 times square root of 3 minus 3 over 3. I suspect they will write that as a single fraction, factored as completely as possible. I don't know that for certain. It's just what I expect. So this would be fine, or that would be fine. And there are a couple other things that would be fine. If you distributed the 2, I don't know why you would, but if you gave me this, that would be fine. If you gave me that, it would be fine. That's why it takes so long to grade these papers. I might have 4 different answers that are all correct. All right, any questions? Do you see why it may be easier to, instead of solving for y prime here, substitute the numbers and then solve for y prime? That'll save you a lot of headache in the homework. That was still a bit of a headache, but not as bad as trying to get that y prime by itself before I did the substitution. All right, any questions? How are we doing? It is noon, so we still have 20 minutes. We're in good shape today. That was number 20. Let's skip to 24. There it is. Here's what I'm going to give you on the test. Now, what if I had this formula written at the top of your test, but then in the problem, I actually ask you for the derivative of arc cosecant? What would be the only difference?
You would have a negative.
I'd have a negative in the numerator or out front. So if I give you arc tangent and arc secant, you can find arc cotangent and arc cosecant just by putting a negative in front of the formula. What is my ugly here? 4x. And we've talked about absolute values before. Sometimes the absolute value is not essential in the derivative, but it allows you to use a wider range of values in the domain. So these absolute values, you need to put them in your answer, but it only gives you a wider range of x's that you can use. All right. The derivative of arcsecant ugly is the derivative of the ugly. What's that going to be? 4. Over the absolute value of the ugly. What's that going to be?
4x.
Absolute value of 4x times the square root of ugly squared minus 1. Now I have to think about what's legal and what's illegal with absolute values. If I have the absolute value of A plus B, can I just take the absolute value of A and the absolute value of B? No, substitute numbers and you'll see. If you let A be 4 and B be negative 2, then you won't get the same thing if you just take the absolute value of 4 and the absolute value of negative 2 and then add them. You will not get the same thing. So absolute value is one of those things that you cannot do term by term. Just like you can't take, oh, I didn't mean that. I meant that. Absolute value is one of those things you can't do term by term, just like taking square roots is one of those things you can't do term by term. But if you have absolute value of A times B, is that the same as absolute value of A times absolute value of B? Yes, you can do absolute values of factors, even though you can't take absolute values term by terms. Same in reducing fractions. You can cancel factors, you can't cancel terms. There's so many things in math you can do with factors you can't do with terms. Yes?
You can write the absolute value for A plus B differently without the absolute value signs.
Say it again, I don't
You
understand.
can write it without the absolute value signs, but you'd have multiple different, it'd be like A plus B and then negative A minus B.
Yes. You can use the definition of absolute value there, but we're not even going there right now. The reason I gave you this note is to make sure you understood what is legal and what is illegal with absolute values so that you can tell me what I can do to simplify this. Would it be legal to say that's just 4 times absolute value of x? Yeah, since that's held together by multiplication, that would be legal. If that were absolute value of 4 plus x, it would not be 4 times the or 4 plus the absolute value of x. And if I can take the absolute value of 4 out of that absolute value symbol, then it would be legal to reduce them. So I'm just going to have 1 over absolute value of x times the square root of 16x squared minus 1. I think that's all we can do. We're not going to rationalize the denominator there.
If it had been x plus 4, you would have just had to leave the x and value.
It would not have simplified at all. And again, Sarah, you can, if you get confused on the test and go, ooh, would that be legal or illegal? Plug some numbers in and see. All right, that was 24. What do I have? I don't, other than rationalize the denominator, I don't see anything else I could do. I wasn't given a point and told evaluate the derivative at this point. I was just told find the derivative. So that's all we can do.
We didn't have any y's, which made it more fun.
Didn't have to use implicit. Well, now, I don't want to say I didn't have any y's because f of x is the same thing as y. But I didn't have to use implicit differentiation because I didn't have y's on both sides. All right. 26 is easy. So let's, oh, no. There is a reason I want to do 26. Oh, I think in the book it was square root of 2x, and I've probably already changed it when I wrote the problem down, instead of square root of 2x, I just went ahead and wrote it as 2x to the 1/2. So the ugly here is the whole 2x to the 1/2. And I know that the derivative of tangent is, or not tangent, but arctangent is ugly prime over 1 plus ugly squared. That's the one I have memorized. So what is the derivative of arc cotangent? Just smack a negative on it.
That wouldn't change that to 1 minus ugly squared, would it?
No, and let me write this down and I'll tell you why. Didn't leave myself room there. John, when you have a negative in front of a fraction, is it the same thing if you just put the negative in the numerator?
Yeah.
Yes. Is it the same thing if you just put the negative in the denominator? Yes. Is it the same if you put the negative in both?
No.
No. So that's why I didn't put it in the denominator. Even if I did put it in the denominator instead of the numerator, it still wouldn't be, what did you say?
1 minus.
1 minus u squared, it would be negative 1 minus u squared if I put it in the denominator. All right, so here's the formula we're using to differentiate arc cotangent ugly. The derivative is negative ugly prime. What's the derivative of 2x to the 1/2? Ooh, so good, Miss Kayla. 1/2, same old ugly to the negative 1/2, and then what? Derivative of the 2x is 2. This is a little ugly inside a big ugly. This is like vugly to the 1/2. The derivative of vugly to the 1/2 is 1/2 vugly to the negative 1/2, derivative of the vugly. Yeah, I'm so sorry that that's caught on tape. All right, that's the numerator, my negative ugly. In the denominator, 1 plus ugly squared. Make judicious use of parentheses and brackets. What? How can I clean up that numerator?
Can you take 2 times negative 1/2?
Absolutely. Yeah. That coefficient is just going to be negative 1, and what else?
Would you bring the 2 extensions on?
You can, because maybe I'll put in a middle step here, just in case you might need it. All I did in the numerator is say 1/2 times 2 is 1. In the denominator, I'm going to say that's 1 plus what? Just 2x. Because when I multiply those exponents, I just get 2x. And I really don't need the parentheses anymore, but I tell you why they help me. They help me because this base is 2x. This is 2x to the negative 1/2. I want my eyes to focus on this is same base to the 1. Now, this is definitely not going to be the answer in the back of the book because I don't leave negative exponents in my answer. Could I use the quotient rule and just say negative 1/2 minus 1 is negative 1.5? Why not? Sounded good to me.
Negative 1 times
Ooh. Well, you have a binomial in the denominator. if you bring that 2x to the 1/2 to the denominator, you're going to have to multiply it by both terms. So there's a variety of things you could write next, but I think what would be most helpful to me is to write that 2x to the negative or positive 1/2 when I bring it to the denominator, and then my 1 plus 2x in brackets to show that I haven't distributed yet. I'm writing down any step that I think would be helpful to you when you look back at your notes. I am capable of doing few things in my head, but just so you'll know what I've done in the next step, I'm going to write this back as square root of 2x times 1 plus square root of 2x, so that you'll understand what I do next.
Why do you have square root of 2x?
Why do I have square root of 2x in the denominator? I don't know. That didn't have a square root right there. Oh, why did I do that? I guess just because I said I'm capable of doing some things in my head, it was time to take me down a notch. Since that was not supposed to have been square root of 2x inside the bracket, I'm not going to distribute. If that had been square root of 2x, I probably would have gone ahead and said square root of 2x times square root of 2x is just 2x. But being as that wasn't supposed to be square root of 2x, I don't see any real benefit to distributing. I think that this is how the answer will be written in the back of the book. And I'm just recopying because it's messy. But I don't think I'd do anything else.
Could you?
Yes, you could. You could. You'd have square root of 2x plus 2x to the what? 3/2. I'm going to put or, meaning either one is okay. But I kind of can anticipate which one they'll have in the back of the book. Which looks simpler, the first one or the second one? First one. And also the first one is in factored as completely as possible. So I'm pretty sure that this will be the answer in the back of the book. Rather than this, on a test, I'd count either one right. If you stick with the rule, single fraction, factored as completely as possible, you're going to be right 90% of the time. All right. How are we doing? Now we just have 5 minutes. Let me write down the homework just so we don't get carried away and forget to do that. Actually, it's on the bottom of the notes, so I don't have to write it down. It's odds 11 through 41 and number 53. Don't forget, I'm taking up 3-5 and 3-6 as 2 different assignments on Friday. Y'all have gotten a lot more advance notice than I intended giving you. I was always going to surprise you with when I took up the homework, but I've ended up announcing it, which is okay. Let's see if we can get one more problem done. Airman, y'all have gotten so quiet, I'm not sure you're still there. Are you?
Yeah.
Y'all haven't left? The one I want to do is 36, but let me show you one thing about 54. In 54, it says find the equation of the line. So you know you're going to find a derivative. And it says where x equals 1, but it didn't give you the whole point. It just says where x equals 1, and you need the whole point. Where will you find the y? By putting 1 back into the original function, what is arctangent of 1? The angle whose tangent is 1? Pi over 4. That's where I got the y equals pi over 4. They didn't give me that. I found it by putting 1 back into the function. Number 40, I just want to show you this cool thought. Now you can do this the hard way and you'll get the same answer, but what do I know about the formulas for arcsecant and arccosecant? If I gave you the formula for arcsecant on the test, what do you know about the formula for arccosecant? It's just the opposite. And what do you get when you add anything and its opposite? 0, and that's the derivative. So just cool if you happen to notice that. If you don't happen to notice it, then you're going to write down both formulas and then go, duh, that's just 0.
So can we do that on the test? Just put 0 if we have something like that?
Yeah, I think I'm capable of knowing what you can do in your head versus what probably Einstein himself couldn't have done. I'm not going to say that. Einstein was so far above.
I guess if you do it on a test, then I guess obviously you would be doing it inside your head.
Yeah, but I mean, if on the test, number 20, for example, if I gave you this on the test and you wrote down that answer with no work in between, I'd be highly suspicious. Okay? That's what I'm saying. I know which problems take some work and which problems don't. 40 would not have taken any work if you thought ahead a bit. 20, I don't think any of us, including me, could have done that whole problem in our heads. All right, last one before we get announced that we're fixing to shut down. I love number 36, and I'll tell you why it excites me so much. Harriman's going to miss out on the excitement because they're packing up already. If you had shown me number 36 an hour ago, I would say there's no way that answer could end up being Q. That's just ugly, and the answer is going to be ugly also. I like how it cleans up though. What's the derivative of natural log of ugly? 1 over ugly times the derivative of the ugly.
Your conference is scheduled to end in 2 minutes.
The same as putting the derivative of the ugly in the numerator. So all of a sudden the derivative of the first term is cute. What about the derivative of the second term? Keep up with the 1/2. And actually, this t over 2, you save yourself a lot of grief if you realize that's the same as 1/2 t. Then you don't use the quotient rule. You just say the derivative of 1/2 t is going to be 1/2. So in that numerator, the derivative of the ugly is just going to be 1/2. The denominator is 1 plus same old ugly squared.